Okay, so we're going to work on solving a very funny spelt logarithmic equation. Okay, so we've been given this one here, and essentially the goal is we kind of just want to work with one x variable. And luckily they are both the same variable, so we're going to see if we can kind of combine them into a function that might be nicer to look at. First of all, this is a negative x, so I'm actually going to make this positive. I'm going to make both of our exponents of x positive, so we're going to find the reciprocal of this. That'll be our first step in going to, so 4x plus, and this becomes 15 over 4 to the power of x, right? Essentially, it's 15 times 1 over 4 to the x, and when we multiply, it becomes 15 on top, is equal to our 8. Now, the question is, can we kind of combine these two? Essentially, maybe we can see if we can eliminate something in this process. In order to do that, I would need to have a common denominator, right, to add these two fractions together. In other words, I need a 4x. So I'm going to have to multiply this, because technically it's over 1. I'd have to multiply it by 4 to the power of x. And whatever I do to the bottom, I'll have to do to the top. Okay. In that process, 4x times 4x is the idea that the bases are the same, so we just add together the two exponents, and x plus x is 2x. So this becomes 4, oops, let's do that in black. Oh, geez. Let's fix that. There you go. This becomes 4 to the power of 2x plus 15 all over 4 to the power of x. Now, did this root help us at all? I see. As of right now, it doesn't seem to be the most beneficial. Where can we go from here? Okay, from here what we're going to do is we're going to bring our 4x over. And I just kind of wrote this in to generate an idea. Oh, you have to give me a minute. So we're going to bring that 4x over. So when we bring it over, it essentially be 8 times 4 to the power of x. And what that'll leave on our left side is 4 to the power of 2x plus 15, okay, is equal to 8 times 4 to the power of x. Okay. So now let's say I decide that I'm going to find the log base 10 of everything here, everything in this equation. Okay. So essentially we're going to find, it'd be nice if I spelled that right, our log base 10 of everything. And I guess I'll use a multiplication sign to say. So the idea is I'll then get log, and I don't have to write the base 10 in, but log to the 4. And what that allows this to do is to come down in front of the log, right? So we get 2x times log 4, okay, plus I'm going to be finding log 15, okay, just a number alone. On the right side, because it's a product, when I go to find the log of these two multiplied together, I can split that. So first I'll write it in. Do our product rule. We'll get log of 8 times 4x. And this right side can be split up. So first of all, on the left, we'll get 2x. We can find out what log 4 is, and we can find out what log 15 is, and we'll do that in a minute. On the right, though, what this allows us to do is, because this is a product rule, I can change this to log 8 plus log 4, okay? And then that x comes down in front again. So what I've now done is I've separated, or I've brought down all of my x's into somewhat of a linear function here. Okay, so what we can do here is first we can collect our like terms. I'm going to bring my x log 4 over my 2, and I'm going to put these two together also. So I'm going to bring anything with a variable of x essentially to the left. So my like terms being this grouping here. Okay, and I'll show you how they're like terms in a moment. And these two are going to be essentially values. Okay, so I'm going to put the green ones on the right and the yellows on the left here. So that will give me, oh, that's not working. It can be hard to keep track. Okay, 2x log 4. Okay, and when I bring this over, it'll become minus x log 4, right? Is equal to log 8 subtract log 15. Okay. And these two essentially become, think of this like coefficients. You know, I could kind of technically replace this log 4 with the idea of y each time, right? And what I'm doing is taking 2xy minus xy, okay? And essentially what we're going to do is we're just going to subtract these x's here, okay? Because this is our base. You could actually, you know what would be a better way to show you this? If I were to common factor. If I common factor out log 4,
right.
Maybe that's a little simpler to look at. And then I'd be left with 2x minus x. Does that make more sense? Yeah? Okay. On this side, we'll leave it for now. I'll just put quotations. What's going to happen is this will just become x. So we're going to be left with x times log 4 is equal to log 8 minus log 15. Okay. And to isolate x, we divide by our log 4. So x is equal to log 8 minus log 15, all divided by log 4. Okay. And essentially this process here is a calculator. Maybe you have a much better looking calculator than me. I will try it on this one, but it doesn't tend to work out so well with logs. Let's see. 8 log minus 15 is equal to divided by 4 equals. I got that value.
Yeah, same.
You got the same? So negative 0.45 roughly. So roughly negative 0.45. That's what we kind of get in the end. Okay, so doable. You have to know your product rule for logs, which I had forgotten. I had to go relook up. And it's kind of just playing with the algebra, isolating an x. But your way of substituting in a value and making a quadratic equation works just as well.